Welcome to my YouTube channel. Learn with @aviboy 2006.
Hello everyone. Hope everyone is doing well. So today we are going to learn about like what is a serverless compute service and what exactly AWS provide as a serverless. Okay, I think many of you have maybe heard that very trending word serverless, microservices, right? Generally. So let me just quickly go. But before we understand like why that called serverless. Okay, sorry, what is the serverless? We should first understand why we should call a serverless. Okay, so it means that there is a not server means serverless. Okay, so let me clear that. Right, I think the
Yeah.
word use that meaning like serverless means like there is no server, but actually there is a server behind it. Okay, but to running the code or managing the data or with the integration of application, all activity can be done without the managing the server. So it like we will not have a like developer will not have a headache to manage the server. They will only have a role to just develop the code and deploy it and execute. Okay, what server is there? What are the RAMs are getting used? Whether this auto scaling is in place or not? Okay, where the timeouts happening are there or not? Developers should not worry about that part. Developers should only focus on the running the codes and managing the data and integrating that particular service to the respective services. Okay, let's take example generally like when we look back a few years back, right? Generally, we build application and deploy the applications wherever to our server generally. Okay, and to run that application on server, right? We all are responsible for provide like provision and managing the resources. Okay, like even if cloud ops also is there, right? Even a developer is not fully involved in the managing a server, but still the cloud ops comes in a picture to manage the server, to scale the things. Like developer has to worry about that. Okay, my server is not scale up. Let me give another request to CloudOps to raise that particular minimum task count or maximum task count or the RAM of the particular server or with the instance type of the EC2, right? So developers are worried about that part. Okay, so in that case, what we generally right, there are few issue with that. By so it like a when we go for traditional way of hosting a server or with the hosting the EC2 or ECS cluster with the Dockerization, right? We get charged for keeping the server up even when we are not serving out any request. Like example, we are running one EC2 server. Okay, but particular that application or maybe service only run Monday to Friday. Okay, and Saturday Sunday there is generally no request comes in a server, but still we have to keep it because we don't know when server request will come, when customer will come to site and see and place the order. Okay, so to keeping that server up we have to get a charge. Okay, because we cannot shut down the server where because there's no request coming in a past history. So we have to keep it up. So in that way of approach, right, we get charged in that server. Okay, even we are responsible for the uptime and maintenance of the server of the all the resources related to the particular server. Okay, and as I say, also we are responsible for applying the any security update required. Like suppose uh, any Python library updated, or maybe some you have remember recently some of the one virus had I think one library Java library was got hacked. There are a lot of patches has to be fixed. It okay, so all the organization run behind fixing that server wherever they are using it in Java library to fix that issue. Okay, so in that case, we are also responsible for applying that patches, security patches to particular server in a traditional way of the approaches. Also, our users also scale need to be scale up whenever the request increase, request decrease, right? So all these are the issue with our traditional approach of the like server management server. Okay, so take example. We have a small startup or maybe small company or maybe individual developer. Okay, they don't have that much of time or maybe they will not they cannot do all these things single alone. Okay, all this listed about all the issues, right? Generally, even they can't afford this charging server for even where the less peak time is there, because even if the peak time is there, we have to keep on 24-hour server, right? And they are getting charged, so they can't afford this part, and that actually results into distracting from the actual work, like what they have to do it. Because suppose example, like we are taking the individual developer, right? Their work is to develop the code and run the code, but still they wanted to keep the server up, right? They will be focusing on this issue also, so they are getting distracting from this main issue. They should always focusing on the building and maintaining the application. And in a larger scale company, this might be the one of a different team handle it. We have a different team which manage the cloud of by infrastructure team, right? And an IT team which taken care of all the resources and everything. So it is not responsibility of the mainly individual. So that was the case, right? Like a small startup or small company or individual developer cannot have this kind of headache, because they want to focus on a very bigger thing. They cannot like have all this alone do it, and even in terms of cost also they cannot afford it to keep around. So I think all our issue comes, right? And someone said, right, when problems or issue come, there are only solutions raise uh, things, right? So that is why the serverless comes in a picture. So serverless, what is serverless? Like serverless is one of the executions approach where a cloud provider, or maybe AWS, Azure, Google Cloud. Currently, only these three cloud provider provides a serverless approach. Others are still working on it, but these are the major cloud providers that are providing it. They are responsible for executing the piece of code by allocating the runtime resources. When I say runtime, right, like developer will say, I'm writing this line of code. I need a PHP. I need this allocation memory. That's it. He will left like that. Then a cloud service provider will taken care of that process. So uptime of the things also will managed by the cloud provider, and they will only get a charge the amount of the resources used for the run code. So when I say only charge for amount of resources used to run a code, so it's like I written a code, I'm deploying the serverless approach. Now I will only get charged when particular customer comes on a site and they place an order. So then they place on an order, right? Means that my service get executed, my code get executed. Only that time I'll get charged. So I will not get charged for 24 hours. So suppose in Saturday or Sunday, I only got one customer which placed the order. Okay, so it means that in my server, only maybe 2 or 3 requests came up. So I only get charged for 2 or 3 requests. That is the beauty of the serverless approach. Okay, when you compare with the cost, right? Serverless is already has on top of that. Okay, so there are some features serverless provide, like automatic scaling, built-in high availability. Like I mentioned, right? It's only charged for amount of resource. So pay for use billing model to increase the agility. And of course, it optimize the cost when you go for serverless. Like you and element the infrastructure management tasks like capacity provision, patching the securities, all these. So these are the major feature of the serverless technology. So when you say serverless, right? Serverless doesn't maintain by the large code base. It will have a small piece of code. Suppose if I have a take a example, right? We have a image warehouse team, right, where there is a service called get image, then get tile request, or get pixel, get 3D something. So each request will have a different code base, and that will have a very smaller code base only. So in a traditional approach where we have a large code, okay, where all one code will serve the purpose of the application. In serverless, it always support the microservice architecture, where we'll have a small piece of the code which runs on the different event. To answer on your query, okay, there are a lot of organizations also adopting the serverless because it remove the headache of the auto scaling part. It also give a space for the cost in terms of also. So it purely depend upon the organization what they are going to opt in on it. But every service has a like pros and cons. Like when you serverless, right? Sometimes when you have a larger request a day, that might one day can cause to the expensive cost. Whereas the EC2 will only go charge for the 24 hour of charge, not more than that. But one more thing is there are part like serverless based on the two concept called cold state and warm state. So serverless always been a cold state, cold start like generally. So when the containerize is already running, or maybe the container is ready to run, it we can say a warm side. So like any other event trigger during this time, it responds more quickly. Okay, that we call as a warm state. And the cold state, what you're telling about, right? It was not run from last 2 or 3 that we call it the cold state. So they are ready, okay, but they are not running currently. So there is a maybe fraction of milliseconds differ from the warm state, and the cold state will be there. And it's purely depend upon the runtime of the language which you use, because each language compiler, execution compiler differ the execution time. Like example, sometimes the Node.js work very quickly. They ramp up the server or maybe execution quickly. Whereas suppose the Python or maybe PHP taking the more time to ramp up that particular execution, that can little bit of lag is there. So it purely depend upon the language which you use and the function of the packaging size of the functions. Okay, I think we'll move to next. So as I mentioned just now only, right, it code typically run inside the stateless container, and that can be triggered by the variety of event, including the HTTP request, database event, QE serving, maybe the monitoring alert, file upload or scheduling. I'll walk through on that, the diagram after this slide. Slide is for that one only, how AWS provide that thing. But just to keep a note on that, like serverless things, like it is like a event driven, based on the event driven architectures also. Like it has a triggers. So trigger can be executed by the API, executed by the database event, or maybe any of the SQS queue also, like any queue based mechanisms also, or even some of the CloudWatch logs also alert, any alert can be trigger a particular serverless. Okay, so code generally that is sent to the cloud provider for execution, right? It's usually a form of function. So when the serverless run, it always first land to the function. Okay, so generally when we run any object-oriented based framework, right? It lands first to the class or the creation of class and then the creation of object like that. But in serverless, it always run with the run first, maybe land on a function, a form of function. And that is why a serverless sometimes we refer as the function as a service, like fast. Okay, so that is why we sometimes we have, you might have heard about like serverless is a fast like function as a service also. So so these are the following, as I mentioned in a first slide, these are the following currently providers of the fast, generally AWS Lambda, Microsoft Azure, Google Cloud. AWS Lambda is a first provider. They started, I think they started around 2016, like generally. After that, after 1 or 2 years, Microsoft Azure and Google Cloud started their functions similar way. But Lambda was the pioneer of the serverless. AWS Lambda was just to give one use case, right? I was working in one of the fintech company where the loan applications was there, and purely that application's full process was running on the 500 Lambda. Okay, and first year, a company never pay any single amount of bill. Okay, because a Lambda comes with the 1 month 1 million request free. Okay, and even up to more than 1 million also, it only charge for the request basis. So when a request come, then only will charge. And that is what the another beauty of the serverless part also. So serverless applications start with the AWS Lambda. So now we'll now move from serverless to the generally what exactly AWS provides generally. Okay, AWS, but in AWS also there are many things they provide as serverless, but Lambda was the one of the major feature of the serverless which AWS use it. It, as I say, is purely event driven compute service. Okay, almost integrated with the 200 AWS services. Okay, so whichever the AWS services are currently available in a console, that can be triggered, or that can be a trigger the event of the AWS Lambda. So what exactly benefit gives this? So I just mentioned one use case of the fintech application, right? You can see in a slide now, like the highlight, it move idea to market a very faster. Okay, why it's faster? Because sometimes you have to deliver some MVP, like minimum viable product, right? And there that time you don't need to write a whole code. You can just write a small piece of code, try it on the market easily with the serverless, because that work on a function base. Okay, get the feedback and iterate over the market how goes faster. And of course, the highlight point I'm saying everywhere is the lower your cost, because the pay for value billing models generally. When you use, then only you will get charged. Okay, it adapts for a scale and it build better application and easier also. Okay, I have an example, another example, right? Axis Bank also using the serverless Lambda service. They have currently, I think, around 10 to 20% loads on AWS Lambda. Okay, they have more recent, I think, way back a year. Okay, but they are like largely using the AWS Lambda. That's one of the use case they have generally. Let me. Okay, these are some use cases. Like we can think about when I seeing the use cases, right? What we currently also using somewhere Lambda or serverless architectures, right? So this is one use case where the a proper web app can be built using the serverless. Not like always a small piece of code or small feature can be delivered with the microservices, but there are full-fledged application also can be delivered with the serverless. This is one of the architecture diagram, like where we will have a domain will route to the like amplify console, or maybe the S3 bucket or any other service provider, like, because when you go for the serverless, you have to opt in most of the time the front end framework like React, Angular, or React.js, Next.js. Okay, and that can be hosted around like any of the service provider AWS, and then it will go to the a particular gateway API. So gateway will have a API called slash to do slash one API, like add to do, complete to do, delete to do, like that. So we can have a multiple services created for the this kind of tasks. So these are a tasks of the API, like add to do, complete to do, delete to do, get all to do, get to do, update to do. Okay, so if you have 5 or 6 tasks or different role of the particular thing, that can be created separate as a service. And it's always a best practices to keep a smaller code for serverless or microservices based packages, not to be mixed a multiple functionality in one single code. Okay, otherwise it will give another, will again go to the a traditional way of the MVC pattern only, like where the large code base is there, and then they then directly connect to the database. So you can see, you can, with the help of this, you can create a simple to do app with that. Okay, this is one of the small example, but as I mentioned that one previously, full-fledged fintech company also created their loan application process on using the Lambda services. There are some more use cases are there, like data processing also is there. Like so there are some of the AWS services you are not known, but these are like where CloudWatch alarm can be triggered. Suppose a particular EC2 or can be reached to the next level of high peak. You can CloudWatch can trigger an event, and which can be listened by one of the microservices or Lambda services. Okay, and that can receive it by email or by by SMS. Okay. The batch processing. Okay, this is one of the best use case. Like a batch processing also people can go for the serverless code base, where because we don't require much processing, much code base to be maintained, that we can have a small piece of code, and that can be done by using the small microservice based packages, right? You can see there are get file inventory function is there. One Lambda is like processing file is there. Once the particular files get uploaded to the S3 bucket, it get listened by the Lambda services, and it go wait for 10 seconds and it aggregate the result. And once aggregated, again it upload to the S3 bucket, and then it's delete the immediate result, whatever the result is coming in. And it can go to the SNS to trigger the next email notification. Like we have done the particular processing of file. Okay. So there are multiple things, like even our EV also, we can think about that purpose, like wherever the image processing happening, or maybe some quality checks is happening there also can be implemented. I think I'm not sure whether it's currently using or not, but that is one of the use cases can be implement by using the serverless one. This is another one, event injection part, like where the PDF docs image extraction model is there. So you can upload a particular doc file or JPG file, and the extraction of text service can be started. Okay, and that can be extract the text, and then particular text can be split into particular files and put it in the bucket again. And once a particular file is finished, add it to SQL queue. SQL queue will analyze that and then go to the next Elastic service, like that. So this is one of the another also use cases. So as I mentioned, like AWS Lambda service is one of the major executor of the, like, supporter of the serverless architecture, and which is supported by the AWS, and also is provided by the AWS Fargate. Also, AWS Fargate also is a serverless compute engine that work on the serverless like architecture, where we use the containerized ECS, and EKS also getting used there. Okay, so I've not used a personally AWS Fargate, so not having much detail about that, but I can uh, give examples of the AWS Lambda, very friendly and good to use model. So how it works? So you can see the Lambda is middle of the circle, and all the services are the triggers by the particular event. So there are many more services are there. I have just kept six major services which largely use it, like AWS API Gateway, AWS Event Bridge, AWS SNS, SQSQ, S3 bucket, step functions. Okay, so these are like based on the event. Like example, S3 bucket, if you upload one file, trigger a Lambda. Okay, if you delete the file, trigger a Lambda. Like that, the event can be listened by the particular Lambda. Step function will be have a like kind of flow, where example of a chatbot, when you particular customer asks, okay, what query you have, next question will come when customer say I have something, or maybe he choose the particular option from 1 2 3 4. Based on that particular microservices can be triggered by Lambda, can be triggered on that. Okay, so API gateway, we see that one of the use cases, right, where the to-do API gateway can be triggered using Lambda. Okay, so this is how generally it works. So it's purely like serverless, and it always be a listen by the multiples event. Let me just show you AWS console. So we have a next session on the purely on Lambda, but I'll just walk through on that, how generally Lambda see. So this is actually Lambda, okay, console, where it will have a trigger to add it and destination to add it also. So when it says trigger is a work like a listener. It keep listening it whatever event is there. There are many events are listed here. You can see API gateway, I like the skill set, Kafka, application load balancer, cloud watchdog, code commit, DynamoDB, MQ, S3 bucket, SNS, SQ. Based on that particular things can be triggered. So to take example of S3, right? When I click on S3, it will ask me which bucket to use it. Okay. And then if you see particular select the one bucket, it will ask which event you have to listen it, like post, copy, multi-part upload, or all delete event, permanent delete event, delete marker. That can be listen here. Okay. So purely it work on the this kind of event triggering only. So this is about the kind of Lambda, but configuration here. Okay, you can see the basic settings here, like memory, what memory is required, what storage will required, and what will be timeout on that. Okay, similarly, which we can, which language we have to use it. Yeah. Yeah. So here you can select the runtimes, like that is why the it purely based on the language specific, right? So there are the latest supported languages which AWS Lambda support: Python, Node.js, Ruby, Java, Golang, Netcore, Net6, and there are some other like container based also work. Currently they are not supporting the PHP at the runtime, but there is a workaround also to support the PHP in a serverless architecture, but there are too much of headaches involved in that. That is why, not sure why AWS has not introduced a PHP, which is very famous language in our serverless their services. And here we can select the which architecture, like based on the ARM 64 or 86 base chip we have to use it. There is SMS. So this is one of the another services which triggers to the Lambda SNS. So let me just go to the Lambda only here. Destination. So it can be like trigger to the SNS topics also, or it can be listen to the SNS from here. If it already available, it will just trigger subscribe to particular SNS. If it's not available, you have to create it.
Thank you for watching session. Don't forget to like, share and subscribe to channel.